So, in this class of dairy and food products, dairy and food process and products technology, in 33rd class, we will go to lactoferrin, but before we go to the next this thing lactoferrin, I would like to go back a little, because I feel you also might have seen, you have also might have heard and seen that in the previous class absolutely towards the end, I was feeling a little sleepy, a little, and obviously that was not desirable, but let me go through quickly that we were talking about protease, peptone and peptide, what are there and what are the differences if they have at all, right. And we also said that the peptide bond is nothing but OCNH, right. That CN bond is the peptide bond. Obviously, it should also have one O with the C and NH, right. That is that carbonyl group and the NH group, they are together bonded to CN, right. And the basic definition of the all protease, peptone, peptide are similar. Peptone is a soluble protein formed in the early stage of the protein breakdown during digestion process, and pepsin converts these proteins to peptone and protease and peptides, right. So, this if we recapitulate a little and then we go to our today, that other this globule other proteins, that is whey proteins, are like lactoferrin. Lactoferrin is another protein, whey protein, which is globular glycoprotein. Of course, from the name glycoprotein, you can understand that it is both you have glycosidic linkage, and this is glycoprotein in the protein, right. And it is around 74 kilodalton and binds to iron, right. And iron, that is the heme, one basic constituent of the blood, the basic constituent of the blood, heme. Iron is and if that is why milk, which has very low, when we will go to the elements or metals or minerals which are present in milk, that time you will see that milk contains many minerals, but iron is very poor, right. So, but this iron is also required for binding with the proteins, and that here it is also that globular glycoprotein lactoferrin, which is 74 kilodalton, and it is bound to iron Fe, right. So, as it contains two metal binding sites. Bovine milk contains approximately 20 to 200 milligram per liter this lactoferrin, 20 to 200 milligram per liter. Variations are obviously there. There are many reasons for those, and it is not that all reasons are identical, but obviously this is a number which is giving the range, right. So, depending on the source, depending on the type, etc., that may vary this lactoferrin content. It is around 20 to 200 milligram per liter. Human milk contains around only 2 gram per liter. So, bovine milk contains much more lactoferrin than human milk, right. Other minor protein includes some growth factors. So, there are many growth factors in our body system. I repeatedly said that you please also consult that book of biochemistry by Leninzer. So, there you will also see these very different types of growth factors are also there. So, those growth factors are also part of this whey protein. Vitamin binding proteins like folate, vitamin D, riboflavin and vitamin B12. So, these are also present and also this one, that angiogenins and osteopontin, these are also present as the whey protein, right. So, after that let us look into that unlike casein coagulates by heat treatment, but not by rennet, right. Casein is coagulated by renin or rennet, that is an enzyme which is available in the stomach of the calf, right. In the stomach of the calf, this enzyme is available and this is rennet or renin, which that is why we are saying that unlike casein, which is precipitated by the action of the rennet or renin, this does not, right, but it is coagulating by heat treatment. You remember while we had said that how different ways we can identify the components of the milk constituents, right, how we can identify. There we had said that when you got the whey separated and heat the whey, then you get some turbidity, that is what by heat coagulate, it is called heat coagulation. So, by adding heat, by applying heat, you are coagulating this protein or whey protein is coagulated, right. So, but not by the rennet, right, maybe in colloidal state or in true solution, right. This may be available in colloidal state or in true solution. Common use of the whey protein is yet to find out, because as I said earlier also perhaps that the recovery of whey protein how much you have is around 20% of what 4%. So, 20% of 4% is around 0.8, right. So, 0.8 say gram per 100 gram of milk. So, to recover this, if the recovery process is not cheap or cheaper or is not affordable, then or after recovery, if the product price is more than the recovery or rather less than the recovery price, then the recovery has no meaning, and that is why till date people have not tried with recovering it much, but again there are many such problems which are for you. So, in future you come forward and try to separate them and make use of it. Till now it is not a consolidated effort of making the use of this whey protein has been made, like the casein, which we have seen innumerable, it has innumerable uses and their caseins are having lot of applications. Like other proteins also, lactoglobulin, fibrin, alcohol soluble proteins are also present in milk. Now, we come to another one, which is the carbohydrate family, right. The other day I had said that milk is the only one where or only natural product where a single component like lactose is present, carbohydrate. This we say the reason being the carbohydrate which is present in milk is basically all lactose. Others are very small in quantity, virtually negligible. That is why by and large milk carbohydrate corresponds to lactose only. Several carbohydrates are there in milk such as lactose, glucose, galactose, and this lactose is made of glucose and galactose. So, on hydrolysis by any way, maybe by heat or by any way, if it is hydrolyzing, then it will give that glucose and galactose, which are also present in milk, but in very small quantity, right. Glycoconjugates are like oligosaccharides, glycoproteins, aminoglycans, all these are also present. Main carbohydrate is lactose, 4 to 45% total present in milk, rather it should have been maybe a typographical mistake. It is 40 to 45% or like that total lactose, main carbohydrate is lactose around 4 to 5, not 45. So, it is 5, 4 to 5% is of the total milk it is present. So, it is 4 to 5% of the whole total milk present is lactose, and glucose galactose oligosaccharides approximately around 1.1 milligram per milliliter, 1 milligram per milliliter, right, 4 to 5 grams per 100 gram, out of which 1 milliliter per 1 milligram per milliliter, that is your 1000 milligrams per liter. 1000 milliliter is 1 liter. So, 1000 milligram per liter, that is 1 gram per 100, 1 gram per liter, that is, or rather it should be 0.1 gram per 100 gram, right. 1 milligram per ml, that should correspond to roughly 0.1 milligram or 0.1 gram rather per 100 gram, right. So, this milligram you convert it to gram. So, it is 1000 grams, 1000 milligram, that is 1 gram is equivalent to 1000 ml, that is 1 liter, right, and 1 liter roughly is equals to 1 kg. So, it is 1000 milligram, that is 1 gram in 1 kg, that means 0.1 gram in 100 grams, right. So, that is what I am saying, that 0.1 gram in 100 gram of milk it is present, right, which is very negligible. That is why again and again I am saying that lactose is the main constituent of the carbohydrate present in milk, right. Others are negligible. So, though and that it is not that mainly they are glucose and galactose, which is the hydrolyzed product of the lactose. So, in any case it could be, but their presence is very small in quantity. So, milk sugar, which we normally know as the milk sugar, which normally we know as the lactose, right. So, which is a disaccharide and it has it is alpha lactose monohydrate, beta lactose and anhydrous alpha lactose. So, alpha lactose monohydrate, I hope you understand, right. So, lactose this with 1 H2O as the hydration is the monohydrate, right. Whereas, anhydrous beta lactose means there is no hydration, that is there is no H2O associated with that, right. So, if that be, then beta lactose has greater solubility and is sweeter than alpha lactose. Beta lactose is greater soluble and much sweeter than that of alpha lactose. Major food source, this is the major food source for bacteria during fermentation of food, and is beta lactose is that is the major source. Bacteria hydrolyze milk into glucose and galactose, right, to produce lactic acid, right, which inhibits the growth of most other microorganisms. Once this bacteria is producing lactic acid from lactose, then that produced lactic acid does not allow many organisms to come forward or to invade the milk and spoil that way. But if it is by lactic acid bacteria. So, if you recall, some other day I had said that if you keep milk just like that and if it gets spoiled, then normally we do not consume because we do not know. But if you put lactic acid bacteria and if that produces lactic acid, then if it curdles, then you know that it is by lactic acid bacteria and it was lactic acid which curdled. So, that time it is not that unsafe, but unknowingly if you take, then you do not know, but if lactic acid producing organisms are there, then or rather if lactic acid bacteria is converting this lactose to the lactic acid, then that lactic acid does not allow other organisms to grow in the milk, right, because they do not tolerate high lactic acid concentration, right. Then which inhibits the growth of most of the other organisms. Solubility of lactose is 1/3 that of the sucrose at 100 degree centigrade, right. Solubility is also much lower than that of the sucrose, this lactose. Prolonged heating at 100 to 300 degree centigrade decomposes this lactose, and which is indicated by a light brown caramel color. That decomposition is indicated by light brown caramel color. This you know that light brown caramel color we said earlier, that is primarily due to caramelization, that browning reaction by caramelization, right. Then we come in the presence of bacteria, it is easily decomposed as cis 12 H22O11, that is the lactic acid, plus H2O that bacteria is fermenting or acting on it, then it is producing 4C3H6O3, that is the lactic acid, 4C3H6O3, and surprisingly you will see that 1 gram of lactose by the bacterial decomposition forms around 0.8 gram of lactic acid. See, is 80% conversion. 1 gram of lactose is converted into 0.8 gram of lactic acid by lactic acid producing bacteria, right. So, this is almost 80% conversion, and that is why that it is coagulated so easily by the this acid producing organisms, right. So, in general around 10 to 30% of this sugar is used in the normal souring of milk. So, only 10 to 30% because the for this is not in this our class, that in the growth phase, in the growth of the microbiology or microbes, you will see that they follow this kind of growth curve, right. So, there is a lag period and then growth period, and then it is the decay period. So, that growth curve we will see that here it is 10 to 30% maximum is utilized for the conversion normally for souring of the milk, that is conversion of lactose to lactic acid. Dry milk contains a very high percentage of lactose because it is with respect to dry basis approximately around 38 to 40%. Because it is dried instantaneously, lactose does not crystallize, but forms a lactose glass, or that is called the glassy state. That is why again and again I am saying that is why before you proceed further for processing milk, you must have the idea about the glass transition temperature, that is the transformation of this to glassy state lactose to glassy state is without forming the crystal. So, this glassy state, what is the temperature of the glass transition? If you do not know beforehand, then during the processing that lactose may create problem forming the glassy state on the walls of the container or on the vessels or on the equipments, thereby it will act as a protecting agent against heat. So, the unnecessarily heat or cold whatever it may be, but if it is glass transition, then mostly it will be heat, and thereby you are losing the efficiency of the system. So, you must know the glass transition temperature of the lactose, right. Then we come that lactose is also very hygroscopic. Under high RH will rapidly take up this under high RH. Let me clear up these lines. Yes, under high RH will rapidly take up water diluting lactose glass to the point where it becomes sticky, and finally crystallization of alpha lactose occurs, resulting to a hard caked powder, which is a serious defect in the product. Okay. Then the other things which are present in milk are the ash or mineral content, ash or mineral matter, that is how it is expressed, but subsequently you will see that the mineral contents are not the ash content, right. However, milky ash contains sodium, milk ash contains sodium, potassium, calcium, magnesium, chlorine or chloride, phosphorus, sulfur, and in these are in relatively in large amount, large quantity, very small quantity iron, copper, zinc, aluminum, manganese, cobalt and iodine, and traces quantities of these are the intermediate that in your periodic table you will see that transition elements, many of them, not the silicon of course. Silicon, boron, they are below that. Silicon, boron, titanium, vanadium, rubidium, lithium and strontium, they are present in trace quantities. Now, parts of this calcium and phosphorus are combined with proteins. Calcium as calcium caseinate, right? Calcium as calcium caseinate and phosphorus also as phosphoprotein, right. So, they are mostly associated with protein calcium and phosphorus. Remaining proteins together with magnesium are partly in suspension and partly in solution. Small portion of sulfur enters into the composition of the casein and lactalbumin. Milk is low in iron, very low in iron, and for this reason would not supply all the needs of an adult, right. That is why milk is not a complete food because of the deficiency of the iron. Had it been that iron is not so deficient, then it could have been a complete food, right. So, if it has to be made complete, so iron has to be supplemented or augmented, right. So, iron has to be given to the milk, then only it becomes a complete food, right. Then minerals in milk is about 0.7 to 0.8%, it is around 0.7 to 0.8% minerals in milk, whereas sodium, potassium, chloride, they are present as free ions. Sodium, potassium and chloride are present in free ion, which are readily diffusible and their concentrations are negatively correlated with lactose. The concentrations of calcium, magnesium, ionized phosphate and citrate, this depends on the casein content of the milk. Concentration of citrate, that varies depending on the season and feed of the animal cow or whatever the mammalian, is mostly true, which affect the soluble calcium content and the milk stability. Equilibrium between colloidal dispersion and salts also influence on that. If the colloidal equilibrium is destabilized, then this is destabilized by the concentration of the minerals may affect, this concentration of minerals may affect processing, which require addition of anions to bind to ionic calcium, that would restabilize the casein against aggregation, that is casein is not allowed to aggregate, right. So, we are at the end of the class this. So, we must thank and complete it today. Thank you.